I think I learned a lot about like kind of what kinds of iteration, what kinds of really small tasks are actually slightly longer than others, because usually in my particular project, that was the problem. It wasn't a big task. It was like these small things that had to happen over and over and over and over and over again that would, it never occurred to me they were problematic, because when you run it in your own code, you do it like once or twice. So of course it doesn't matter. But when it's happening like thousands of times, all of a sudden it becomes an issue.
Yeah. Also, like I started to optimize more when I killed my session more frequently in my
Yeah.
experience. Because then like you kind of come also in this anti-pattern. I don't know if it's the correct term, where like you don't want to rerun everything because it was slow. So then it leads you to like errors that you paid async laters.
Yeah.
Like if you have long scripts that take a lot of time, and as you say, like for example, processing them or big imaginary image files,
Yeah.
raster files, and if it start to be like slow, you start to go into pattern where like you are not like necessarily like
You don't want to,
testing. Yeah,
yeah.
you are not into a feedback loop where like you are testing, experimenting, which is like the value of R. And you are like in, yeah, I don't know. So I think this is my my take on measuring and improving performance. Like if if something is leading you to mm, uh, uh, being afraid of shutting down your session, it should be in some way either optimized or you should cache the data in some way, I think.
Yeah. You did make me think of another time. I think I was working with optimizing a workflow, which is unusual. Usually optimizing just functions within a package, and I think it was because my memory was dying. So my memory was actually like broken, and I didn't realize it at the time, but I kept getting in like having problems with running things. So I kept going more and more optimizing it so it would go faster and faster so that it would have less opportunities to like run into faulty memory.
Yeah,
That was frustrating.
this lead me like to another take. Like I don't think the book bring it too much also. Uh, which is like you can optimize for speed, you can optimize for storage, you can
Yeah.
optimize for bandwidth, you can optimize for a bunch of stuff, and every time you make trade-off, which is fine too. But like the funny story is that I finished my PhD with a Raspberry Pi, so I was very conscious of my memory.
Oh yeah. Awesome. I have so much memory on my computer. Like it's ridiculous because I just
No,
keep,
no, it's the same as you. I don't care anymore, or I care way less. But I'm always afraid that at what time, like the time where like we're gonna need to use go back to prehistoric age. We're using small computers, and we will need to optimize for everything.
I find that
But
yeah, I go through
yeah,
phases depending on the project where I have to be really careful, and then I can be in another project and be really sloppy. Um, but
here like yeah, here the measuring performance we are measuring, and the measuring like and the improving chapters like we're gonna see all focus on the speed, so the compute side of it.
yeah.
But it can definitely be a problem like for big data sets also sometimes.
So I was going to say, you were mentioning about the reading, like the IO input outputs, being kind of limiting. And one thing I just thought that was kind of relevant, I recently had a project where I was working with giant quantities of data, and it was mostly in a MySQL database. And so I was working with that in R back and forth. And I actually found that for the purposes of what I was doing, it actually worked better to have them as Arrow, or I think they're Feather, Arrow or Parquet. I can't remember which one I ended up using, but I experimented with both. And on that note, if people are really excited about learning more about Parquet, I just, for our OpenSci, managed to secure a new co-working session in January 14th. And someone, Rainer Krug is going to kind of co-host with me talking about using Parquet in R, which is super nice and blazing fast. And
Yeah,
works.
this is very like I'm definitely excited by this new format of storing. So Arrow usually is the in-memory format, and Parquet is the writing format, like a storage format, my understanding. And yeah, there's also like question I have, like, so you can like my like appending to this file also are complicated.
Yeah. Yes.
So this is
Yes.
something like it's
Yeah.
also like another level of optimization. Sometimes, you want to row-bind stuff. And sometimes if you need to generate all the indexes, all the metadata that are on the header of the file, all of that can also like take some time. So optimization, I feel, is a very big topic, at least for me. Like I do not know a lot about them. And I think 2 chapters, but just focusing us on memory is already like, I mean, that's good enough. So let me share my screen first. Also, maybe we can start quickly. I mean, except if others like have taken that. But yeah, Derek, definitely small computers are everywhere. We just don't see them. They have no screen. Let me share. Share. Let's go back to 23. So here, like the measuring performance, as we said, definitely just focus on making it faster. And the big take is like it's hard to understand where your code is slow unless you spend time into data structures and algorithmic, which is not necessarily our training, I
No.
feel. So this is maybe also why like Hadley focus on like and maybe like experimental tool. We're gonna call them that way. Yeah, you are not like, because like you can see people in computer science write algorithm by hand and trying to understand where the bottleneck is. This is not us, or at least it's not me. And yeah, this is definitely like it definitely advocate for an experimental point of view of that. Like bring your code, test it multiple times, do statistic on it. And yeah, well, this is a citation, by the way. It's a citation from the book, weirdly. Move on, please. It's slow today. So they use two profiling tool, Provis and Bench. Bench is for benchmark and micro benchmark, and Provis is basically a wrapper. So I'm not gonna go into that function. The interesting points that I didn't know, I feel stupid when I read that comments, is like if you do C-sleep, obviously the time for C-sleep is fast because like it just like said sleep 1 second. So this was funny. I never realized that. So I feel stupid not realizing that, but that was, at least I learned something. The function is pretty stupid. It's just a function that stops 1 second and that call another function, that call another function, etc., etc. No really like interesting stuff of that. I think what's interesting also is like it's kind of like you can generate a dump and you process it. And what the prosvis package does, it just simplifies this dump. Like I think rprof is maybe from base R. And basically what prosvis does is doing like this nice visualization of top of it. Instead of generating like this big dump that's basically like generate a bunch of time the call and stop them at various times. So I was like, it's all about that. And ERC, we have also like the function from the book. If you look at that, if I do that on my computer, I will not have like xfun. This is a function from UE package that's probably used from like so instead of just having like the GF eval pause, etc., because it's running Air Markdown, it run a bunch of other stuff. At least this is my understanding. If I go into the book, is it still RStudio here? Do I have it here? I don't think so. Yeah, I don't have it here saved here. But yeah, it should generate it should generate another, like, it should be different to what we see in the in the book, which relates sometimes also, like when you are doing literate programming and you want something to go faster, maybe it should do it to an R script, because then you do not have the overheat of using the literate programming tooling. And then you can use prosviz that generate like the nice data either directly in memory or etc, etc. Obviously this is slow. I don't think it works because like it did not, like, I don't think the book generated it. I don't know if I want to solve that, by the way. So we'll need to generate it here. And well, it's slow, but like it's relative, no? So I have like this computer is 16 cores, and it's a really recent, but it's probably just one core, by the way, I think. So it's just like one core and just the processor. I don't know what processor it is, but yeah, it's super fast. Because like this is like 60 millisecond. I don't know. I still haven't not wrapped my mind around the garbage collectors and how frequently it does. What's something? Someone's shot something. It does not take that much time here, no? You know, I mean, and to be fair, like, yeah, I don't, that, how can I say that? If you want to optimize the garbage collector, Hadley gives some advice, but I feel most of the performance is on the C backend library probably. And it's probably dependent also on your operating system. So I think this is out of the scope here.
I think I meant more like that you could avoid requiring garbage collection, and that's like a strategy. It never occurred to me that that could speed things up too.
Yeah, but usually if R is garbage collecting, it's garbage collecting for a good reason. And I'm always afraid of that. I'm not saying like you shouldn't do, but
Sorry, I didn't mean to prevent R from garbage collecting, but to write code that didn't require garbage collecting.
yeah.
Because you said R will do it when it needs to do it. So maybe write your code in a different way so that it's not required to do it. And that might actually speed things up, even though you wouldn't. Because I think when I look at some code, I'm like, well, the actual operation isn't that slow, but it's the garbage collection that's taking time. So if you could rewrite it so the operation takes the same amount of time, but you don't have any garbage collection, then all of a sudden you sped things up, even though I don't know
if it's not that much, no.
if that makes sense, but it made sense to me.
Yeah. It's help understanding if it's like the bottleneck could be the garbage collectors. I agree with you. Here, like the optimization of that code is fairly simple. Now you should generate the size of the vector first and populate inside of it, instead of creating every time a new vector that you are appending. So there's not really much to say about that.
One thing that wasn't clear to me is how is this profiling, can you use it for non-functions, for like, you know, like if you just have a big script doing your data, you know, your data analysis, does profiling work at that level, or is it only apply to functions?
I think it's only applied to what you can identify as, for example, like to eval and stuff like that. They're probably like gonna rewrite stuff as a function, but I don't think like you can like, because everything is a function at the core of R. A lot of things are function, even primitive.
You can profile like lines in a script though. If you have like a workflow, you can like, if you go there's like a profile button in RStudio. If you use RStudio, there's like profile button and you can select lines and then say like profile selected lines, and it'll like the and so I've done before.
Is it?
It's up above on the top main bar. By debug, it says profile there.
Oh, debug.
Sorry, next to it, next to debug.
Profile. Yes, start profiling.
You start, but profiling selected lines, I personally find a little bit nicer because start profiling just keeps going. And I always
Because you don't specify how long you want to be run, no?
yeah. So I like to like kind of have a piece.
It's running on the background job, not even. It's running on the main R session also. So here, yeah, that's weird because like I have my session available.
But you have to actually do something now, I think, because it's profiling, but you haven't done anything, right?
Oh, I need to I need to run, yeah, correct. But like it will be super fast here.
Yeah, but then if you ran, nope. Maybe not. What I would consider doing is writing like in this, yeah, not the this part though. That would be that way.
Session, profile, start profiling.
You're gonna profile your profile.
What?
You're
Oh
gonna
yeah,
profile
I need
profile?
just this for loop.
And then you can do profile selected lines or run them if you've already started profiling.
Stopping it, and here I have it.
Yeah.
Oh.
So that's, I think, the error you had earlier.
Yeah, it's
I think
because it doesn't run anything.
profile. So if you go back to your RMD file,
This one.
yeah, and now just go up to profile and click profile selected lines. Sorry, not the profile menu. Sorry. There you go. Go back to your RMD script to make sure those lines are selected. All right, so now they're selected. And now go to profile selected lines.
And here I did not garbage collect.
That is interesting.
And
maybe if you want to see garbage collection, you need to do it differently.
I prefer that because then you have all the call, no? By the way, I don't know what that was called.
It's the error, I think. This was when we were, but I'm not sure.
So profile, good.
This is like a good use if you have like a pipe or something that you're working through, or like a little piece of code, you got like a long workflow and all of a sudden some parts of it seem like they're taking longer than they should. It can kind of give you a sense of just checking out where things are.
Yeah, just have a call, function call. So I don't think you can access it. Okay. I think I prefer understand like when I generate, I prefer have a script, send it, and get me a file that I can like investigate. But that's maybe me. Okay. Okay, profiling a loop that's modifying existing variable. We all know that it's bad. Do I need to explain why? Oh, it's explained here. So you are copying on modify and everything. So you are regenerating a new X, creating it. And I think also, correct me if I'm wrong, but I think also like R is gonna free the memory only at the end of the loop. So it's not like it create the new file, it create the new X, free the whole X, create the new X, free the whole X. No, it's gonna keep growing the X until it exits the loop. It's gonna keep like the memory open until it exits the loop, which is bad. Okay. So my workflow, I mean, if I need to profile codes, is like I'm gonna use that and use the prof on the file because I think it makes sense for me. I'm gonna source the script and run the stuff. And why? Because I think it's a good workflow. Is like if I can't produce a script and if I'm only on interactive mode, I probably have a bad understanding of what I'm doing. Next. Micro benchmark. So people love that. And I think it's highly dependent of what your computer is doing right now. And people like I love posting their micro benchmark, and that's kind of cool. So basically how it works, if people are not aware, like you are writing expression, here it's 2. And you are wrapping up into a function call that spark the expression. I'm kind of curious, how does it work behind the scene? Because like what this function mark take is like, it's taking like, I guess the X is passed because it's in the global environment. And then you are passing this mark function is gonna run these 2 expression and compare them. And usually what people do is like they wrap all their big scripts into a function. It's nearly a whole workflow, and they benchmark the whole workflow. And now that I have seen the previous chapters, I will use the previous tool, I feel, which is basically the source and visualizing it. What Hadley advice is you should look at the mean and the median also on this. So you have like these 2 expressions that we benchmark. I was super surprised, by the way, why the function was so slow. Imagine we are in nanosecond here. And why like it was like the other way of doing it was way faster. And he explained it like because like apparently square root does a bunch of other stuff like testing the NM, stuff like that. And I was not aware of that. Yeah.
I think it's actually the opposite. Isn't square root faster?
Oh yeah, you're correct. So the other one, sorry, yeah. No. Well, micro and nano bigger? I never know.
Nano is bigger. I just had to confirm this myself today because I
So
couldn't
nano
tell.
is bigger. Yeah. So this one is bigger than the other one, no?
And I think square root's a primitive function, so I think it's C. Is that why it's faster?
Yeah,
Maybe.
My read is like, let's see, maybe they see it is like, if I
But you
remember, the answer was like square. One of them is applying some test.
I don't think so. I think if you look in the figure, you see that
Oh, the figures. Yeah, so square root is faster.
Yeah.
You're correct. My bad. Did you say why?
I don't know why, but I was looking at it, and I think square root, they say it's not primitive. That means it's a C function, right?
Yes, that means
then
that or C or another language. It could be Fortran.
Oh, okay. So
that we don't know.
Faster language then.
Yeah.
But that's my guess. But I don't think he said why.
Another risky optimization is to directly call the underlying internal function. This is faster because it does not do any input checking. So both of them are doing input checking, but you can optimize the square oh no, it's not this one. It's the mean on the book. It's not square roots. So you can go a bit deeper. You should have just oh yeah, because yeah. No, I think the other part 23. Why? I want to be sure of that. It does not seem it say, no? So micro is smaller, you're correct. But you don't say why. Okay, at least I don't find it. Well, I prefer this version than this version. I think I never like, just because the order operation is cleaner. Okay, then I think we always, okay, solution, I don't care. This I don't care. Improving performance. We agree on that. I think we already discussed the code organization. What's improved performance is just first organize your code and avoid like just rereading what you have missed. Check for existing solution. Yes.
I think for me, that's like, I usually check to see, is there a faster function?
Yes, but yeah, yeah. Do as little as possible. This one, I use it a lot, especially in the spatial ecosystem, because a lot of spatial operations tend to generate overheats and copy pasting stuff. Like the most example is sometimes you just want to know like what's a polygon intersect another one, and you don't care to carry out all the other information. So instead of doing a full intersection, you just can do an over and stuff like that. So we're gonna go review it. Organizing code, we have seen that. Check for existing solution. I didn't know like the trick of that. I didn't know also like the API from Stack Overflow. I usually search directly for it. I don't know if you use that, but yeah. And the multiple communities, sure. I guess people tend to be lively on the posits channel, but I never go too much into it. It's community or studio. Did they remain? Did they still working? Yeah, it's for Posit. No, they're redirected. So I should maybe edit that. But yeah.
Another our OpenSci plug, our OpenSci has a semi-open Slack. And so if you like review a package, submit a package, host co-working, participate, do a blog post or something like that. If you do anything for the our OpenSci community, you get a Slack invitation. And there are some really kind of persnickety esoteric questions that you can ask in Slack that are kind of fun to watch the development of those conversations. So if you need to do some co-working, you can always contact me.
Yeah, do little as possible. I don't think like maybe this like okay, maybe if you just want the raw sum and the call sum, etc., it's maybe better to. But I think this function usually are pretty fast. But I mean, the apply min on the apply my data one min is pretty fast. I didn't know like the apply was faster than sapply, just because you enforce the type. I just think like it's neater because like you enforce the type, so you kind of know what you get. This one makes sense because yeah, you're asking a way bigger question than this one. So all of them, I think, are simple questions that everyone can use. But I feel like it's also domain dependent. Like, as I said, in special operation, I know what kind of predicate are costly. And if I can avoid doing a predicate is testing, like if an operation, like if let's say like A is inside of B. And you have a lot of stuff that can take an overcost. Like, for example, do you want like also like A is inside of B, but do you want also A is inside of B that's touch the borders or not touch the borders or a bunch of other stuff. So I think a lot of it is using the list is always good. And I saw like my take on that is also easier to debug. So it's not necessarily optimization. Also like, yeah, doing stuff on list usually is faster than doing on table for some other reason. This one maybe I should mention. Avoid method dispatch. Well, I don't know too much about that one. Because sure, for this kind of tool, this is the example that I was confused with square root before. I don't know much about it. I think the safeguard are usually here for a reason. The rail guard, sorry. And being using like the method dispatch is one way of implementing rail guards. I don't know what you think about that. Like, will you obviously with internal min it's faster and well you are really like not gaining much, but is it worth like worth it? I don't know. By the way, I didn't know you could call the internal function that way.
It just always seems a little like you'd have to have a really rigid structure, I think, that you knew was safe, and it'd have to give you a lot of savings and time for me to use this, I think, because it just seems so dangerous.
And then like, you know, if you are not doing like if you're not letting the function do the test for you or the assertion for you, you are basically gonna do it before. So you are gonna do an ask character or ask something before to test everything is, so you are kind of re-implementing it on the before.
It depends a little bit. Like if you had to do something, I guess I always think about this as if it was in an iteration, if it was in a loop, you could kind of do a broad test on things quickly once beforehand, and then send it through the loop if you knew after testing it was fine. But I'm not certain if it's worth it in the end.
I never know about that, but maybe it is. It's good to know, I will say. Avoid input coercion, yes. Yes, okay. This is basically rewriting everything into memory, is my guess was it's slow. So it's gonna like convert everything and then rebinding it. And that's why like it's better maybe to write with list also. This is another example. Also like I was kind of curious also because like, for example, if you know rowbind, the dplyr version of airbind, it's usually faster, but it's gonna create new column if you are binding stuff that does not have the same column. So in this case, is it a case of coercion also?
I think it gives you a warning if you have a column that's the same name,
Yeah.
right? Or is that what you're talking about? You have columns of the same name but different types.
Yes, it gives you a warning. So it does some stuff. So all of that makes stuff like if you are using, for example, airbind, will it be faster if you know like you have all the same column, or will the rowbind be faster? And also like if you have like missing, for example, airbind cannot bind data frame or other like row or matrices. If the matrices you don't have this issue because this is the same type. But if you have like different kind of name or different length of the tables, different dimension, it's gonna rowbind will generate ANA, which is convenient and bad.
You need to do a micro benchmark.
I will not. My flag on that is like, do I have dplyr needed and loaded? Then I'm gonna use dplyrs. And if I do not have dplyr loaded, or because for some reason, then and I know the data is fine, I'm gonna airbind. But the default of using rowbind is like you need to check by yourself and you be sure like the name are the same and the value inside are the same. Rowbind is just gonna throw you an error, which sometimes is valuable. And so like you can vectorize. By the way, there is a vectorize function that can help you do that. I don't know if you ever use it. I have read code with it and I've changed, but I have never conscientiously write one. So I have seen code where like this is this function like.
I think in theory I know of it, but I don't. I haven't.
I have no idea how it works.
Yeah.
I think it's a capital V.
They're also just as a note, there's also like p min, I think, and p max if you ever need to vectorize min and max.
Yeah, I have used them quite a lot. Yeah.
Yeah. I don't know that I've ever done. I knew of it, but I think it just seemed overly complicated.
My understanding of the vectorize is you're gonna be sure like you're gonna call the fast implementation on the C side of it, and that's why you should do it.
Okay, good to know.
But that's my understanding.
I'm definitely not versed with this, so that's good.
Yeah, me neither. I have just seen it a few times in code that's unmaintained.
I'll have to do a micro benchmark to see if it.
Yeah. No. Avoiding copies, the the classical example. I think, and you know why, like, okay, it saves time, and maybe we said that a lot of time when you said avoiding copies, but I think most of the reason like you should avoid copies is because like you can modify multiple states at you can have multiple state at multiple places, and here like this is not such a big deal because like the function is very clear, but you could have like usually what I see is like people defining an object on top of a function, then redefining letters while it's still the same object. And when you update the code or try to change, then you have two places where you should update it. So avoiding copy for me, yes, it saves times, but for me, it's mostly like having a linear code. So I think it saves more time for me having a linear code to maintain. That's just saving the time to run the code. That's my take on it. And then Hadley, when in a complex example of t-test, that's, yeah. How you can optimize, but like t-test are super fast. I was like, when are you going to run into an issue with t-test? Did you run into an issue with t-test one day? Never. Anyway.
But if you start doing like some fancy stuff where you're doing a bazillion iterations of it, maybe then it matters.
Yeah. Like if you do a Basilian operation, you should rely on C already, no?
Well, I mean, I don't know C though, so
Yeah,
that's
that's true.
not accessible to me. One thing I was going to suggest too is that he says to like kind of keep track of what you do, and I definitely done that in packages where I'm working on a package for someone else, and I call them like they're called devtest.r scripts, and I'll put in benchmarking notes in there because especially if I'm changing the code from what the original author had to what I think it should be, and it gives me like it's nice way of sharing with someone exactly why you're doing something, and also
Yeah, no. And to be fair, this is the second time that he said that, because he said that on the Jeffrey's debugging tools.
yeah.
So I think he is really doing it. You know, one can be a fluke. Two is like that's mean like he has maybe a small book where he notes, or like a place where he notes his experiment and is very meticulous. So I don't know. I think I should aim to do that.
Yeah, I wanted to know what this recording system of his looks like. Does he just have like one file somewhere on his computer? Does he have it like a journal? Yeah, how does he track these types of things? Yeah.
That's a question. Like next time, like we can ask a question like, how are you tracking that? Or is this just posted somewhere? Like I think Diana, no, you're the one with the post-its, no? I remember correctly, yes. I don't have here, but I use also post-it, so I'm not blaming you. And then after I stick them I stick them in the that's the worst, you know. And but I do that too. Anyway, so I think is, yeah. I would like to do that, but I don't think I'm doing it enough
I do
conscientiously.
in projects, but I think it's easier to do it if you know that you have to explain it to someone else, because
It's
then
true.
you're kind of forced to. If you only know that it's your future self, you're kicking in the ass, then like, it's it's easy to be mean to your future self than it is to be like mean to your colleagues.
No, but also like verbalizing your thought is usually a good way to understand it. Because sometimes, or I don't know why I'm not a brain expert, we shortcut stuff. And we think like we understand it, but like then when we process it, we realize that we shortcut some step. And so writing everything probably like make you feel more concentrate, or I don't know. There is some, I
It
don't
is
know.
very valuable. We just don't do it unless we have to often.
Yeah, but then I agree with Jeffrey, you need a system for that. Because then it's become very painful, no? I'm using book. I'm terrible. Like I'm using notebook.
Yeah,
But then
The problem with that is it's not searchable, right? Like to me, it's always like search is so important for something like this, right? Because you're like, oh, I have this problem where I need to do this thing. And so you need to know the words that you used before and be able to find them pretty quickly.
I also have a gigantic node file,
Yeah, yeah.
which is a big org mod
There,
file where I can
yeah,
search for it. And
yeah,
I have
exactly.
one per year,
That's it.
which is totally awful. I not recommend it at
Well,
all.
I'm definitely not like yeah, I have to remember what project it was that I did something in, and then I go
Yeah.
look at the
Mhm.
project notes,
But
which
that's hard. If you're doing
yeah,
a lot of projects and if they're very similar, like because this is the same thing. Like for me, my projects are all like the research papers that I'm working with, and I'm like, oh, which like because they're also we all experience evolution and change how we do things, right? So if you go back too far, it's like, oh, that was back when I used base R instead of tidyverse, right? Now I got to think and trying to keep track of that, like remembering, like, yeah, I've done this multiple times. The first two times were terrible. It was the third time where I finally learned how to do it right. Now, which project was it that I did that in? Like, this is my struggle with this is like, how do I organize these things in a way where I can track track them and usefully find the information I need? And I'd love to have feedback on how to do that.
I don't have good solution. Maybe others have.
I was gonna say, well, one thing you could do is if you do it in this project and you're really happy with it, leave yourself a note somewhere else being like, oh, I solved this problem in this project. And that way you've got all your notes that are very concise, somewhere. I use Workflowy for my notes, which is just super cool. And I've always kind of thought I should keep track of our code in there, or our tips and tricks and stuff, but it's not like a notebook, it's not like for coding. But now that you just said that, I'm like, oh, that's what I should do. I should actually take notes in my Workflowy about kind of problems, and don't put the solution to the problem in the notebook, but put where the solution can be found, like more of an index.
Yeah, my
Yeah,
wife
but
also uses Workflowy and she's happy with it. So at least two people, I know two people that like it.
sorry,
But yes, I like a big dump file that I can git because
Mhm,
also like then I can search for it in with it.
mhm.
I know people like Obsidian and Notion, but I have not tried them. This is two
So,
kind of a Workflowy bigger competitors. I will say Workflow is more straightforward. It's more like one focus, but Obsidian and but then yeah, people like Notion a lot, but I don't like not being owning my own file.
Yeah,
Uh,
I like the idea about just going back to the code actually and commenting more in the code. Because then assuming you keep everything on GitHub, you actually can search GitHub, right? Like that's where all of my projects are, I have GitHub repos for them. And then you can and apparently like the search for GitHub is just becoming more and more amazing. So yeah, that might be another way of doing it without having a separate, because this is the thing, is any additional step beyond like what I already do means that it's less likely to happen. So creating this outside document to keep these notes for me, it's like it's outside of outside of my typical workflow, and which means I'll start doing it and then like 3 weeks later I'm done and I quit. But if it's something I can do, like build directly into my existing workflow, and then use some other tool like, search in GitHub or something, maybe that's a good solution.
I mean, you
yeah,
probably
there
already
is also like small
like
value while building a package for that.
yeah,
Like if you building a small personal package, like if you are running into something, like maybe you create a function that does that, and then you have it in your small personal package. You don't care to, like it's just your small. And I think like the xFun function of UE, I don't know if you never look at that package. I don't know if I will be able to find it with
Yeah,
the name.
no,
It's kind of,
it's like the HMISC. I don't know if you use HMISC, but Frank Harrell's like collection of miscellaneous functions he threw together and then put it on CRAN, and now a bunch of us use that. But yeah,
yeah,
that's
that's the same, but that's the
yeah.
UE version of it, I
And,
guess. And
and
it
I've
started
done
like that, but
yeah
like, I'm pretty sure it started by just, like having like a function that it needed,
yeah
or like you read into a project that it stored somewhere, and then that's it.
yeah Yeah, no, I have something like that where it's like if it's a specific function that I'm writing, but again, I don't do a ton of functional programming, right? Like I'm just analyzing my data. But yeah, if I'm writing functions where I'm applying stuff over and over, I did create my own kind of version of that. But this would be more like this is just like a problem that I need to solve, rather than a function to do something. It's just like, oh yeah, this is the kind of thing I need to do, and like I can never remember how to go back and find how I did it last time.
You're
Yeah.
probably aware, but you know, in our studio, you can search in files, like for text inside files.
Yeah, the problem with using files is I move like how I store my projects makes it a little tricky, right?
You can search the text. So what I would do if I'm looking for something like this, I go to search for something, and then I go up a couple levels. So I'm in my project folder. So my projects folders contains all my projects
Yeah.
that I work on. And then I search for text inside all the files in those projects. And it's a bit of like a shotgun blast, and it takes a little time, but it can be useful, I think. Is that?
Yeah, and that like I said, that's where like my organization I would have to go at basically my home
Oh,
directory to do that.
yes,
I
yes.
move, I have like projects I'm working on. That's where that would work fine. But then I end up moving them I move those folders into other things like teaching or research or presentations to get them
Yes.
out of my kind of current. And so I'd have to go up really high to do, and maybe it still work. Like maybe just given, like we are talking about before, maybe just given the speed of computers now, actually the search would still be perfectly
know.
fine.
I mean, people are trying to sell you LLM to do that, dump your
Yeah.
memory and ask a
Yeah.
large language model what it's going to generate. I do not believe that, but yeah.
So actually related to that, it seems like I heard, maybe this is useful too, that there's like local LLMs that you can basically, there's some kind of system where you can build it on your local work. That would be useful. Like if I don't necessarily want to use ChatGPT, but if it's like the local LLM that's trained on my code, or that would be potentially useful. Does anybody know about that at all?
Yeah, that exists. People are doing it, yes. Go ahead,
Yeah.
Steve.
I was gonna say, sorry, I got really excited, but I keep interrupting everyone. So Mark Patcham from our open side, he created a package called Package Match that you install a local LLM, and it allows you to see if the functions you're writing sort of match functions in another package or match another package. Full disclaimer, I did try to test it out for him, and I like kind of broke my computer because it's a very big download, and I don't know, it might be my own problem because I don't think it's supposed to be that big of a download, but yeah, it uses the Open Llama, I think, or
Yeah,
Ulama.
there's a lot of talk about it. I don't know like how good it is.
Yeah.
But
I ran out of space on my
people are like, there's plenty of stuff like people who are building it and stuff like that. I don't know. Let me finish the other technique first.
Oh, sorry.
That's fine. Okay, you should read plenty of her blog because they're amazing and people put a lot of their soul into it. Not necessarily to optimize your code, but just to contribute. Read other air programming tool. Disclaimer, I have read a part of the art of air programming from MATLAB. It's super heterogeneous. So I will say some parts.
Can you say what you mean? Can you say what you mean about that?
Some I think are super basic, and some are like, it's oh yeah, sure, you should implement a queue system. Yes, sure, Matt. How do you do that? So yes. So I kind of sometimes I read the chapters, do the exercise. It's exercise EV also as a book. So, but yeah, I never read the Inferno. I just know about it. Take an algorithm on data structures. Sure, you can. This is basically it. Transform yourself in computer science people. Why not? Learn how to parallelize your code, obviously. But there is another hit as parallelizing your code is at one time you need to group your stuff and divide your stuff. So also like you need to be able to divide your question in multiple places. For example, when I work with spatial data at the size of America, usually I'm going to divide by every state, for example, and then I'm going to run in parallel for every state. But here, because like, except California, which is huge, and Texas, which is also huge, all the states are kind of like, there are entities that are similar enough that I can run in parallel multiple process divided by state. But that's mean like you can divide stuff on specific, on specific size. You have units that can divide it. Yeah, for that, yeah. The name is crazy also, by the way, of this package. And I don't know, read them. I never read the pragmatic programmer. Everyone said is great, and basically share with other people. So my take on all of that, on all these chapters, is like basically try the whole optimizing is like try to be better at coding. And that take times. And that's maybe one way, like, that's why you should be more like scientifically minded when you do that, so you can progress on it. That's it. I should tap ends.